Well, if someone wouldn't mind getting that door in the back, I'd appreciate it. And thank you all for coming to Koop. It's a platform for data interoperability. I'm Daniel Fenton, software engineer with Esri in our Washington, D.C. R&D Center. It's also the team responsible for ArcGIS Open Data. So let me just talk a little bit about the motivation for Koop. There's all this great data out there, but the APIs are often incompatible, especially when you're working with third-party services that kind of have their own business, maybe have developed their own web clients and things to work with that data. So how do I get great data like this about apartments, for example, that Craigslist has? Everyone knows that Craigslist is the best provider for renting houses and little apartments and things like that. How do I get that data into a map like this, where I can do analysis? And please excuse the horrible cartography. I'm sure there are people here who can help me improve this tremendously. But how do I bring this data together? Because Craigslist's API is compatible with literally nothing. And as you'll see, the answer lies in, I guess that disappeared. But the answer lies in this. They're actually giving away all the data in a JSON format, and that gives me something that I can work with. So that's kind of what we want to do. We want to bring data together because any one data set is much more useful in context. Like apartments are more useful where you can see rail lines, where you can see how far away it is from your office, things like that. Just features that Craigslist doesn't provide, Zillow doesn't provide, or there are many, many other applications for this kind of thing. So I think the best way to think about Koop is kind of this universal translator. You teach it a new language, and then it has facilities for making feature services, and you can do plugins to create like OData adapters and things like that. It's very much a kind of a pluggable architecture. So it's this layer between, as it started out, between all these different APIs like Socrata, CCAN, and creating a feature service that you can bring into a map, you can bring into QGIS now. Once Koop has GeoJSON and kind of the route of request, it knows what to do to send out the proper response. So it just needs to be taught how to speak to the remote API, that underlying service like a Yelp, a Zillow, CCAN, what have you, and how to translate that response into GeoJSON. So it really is kind of the lingua franca for Koop. Once we have that, we can make feature servers, we can do raster and vector tiles, geohash aggregations, and export to other file formats. So really focus on translating it, and then Koop has all these kind of magical powers to help you out with the rest. So ArcGIS Open Data uses Koop in production. That's been a big customer for it. And we run kind of what's called one provider, and I'll tell you a little bit more about what the concept of a provider is. But we use it to liberate all the data from ArcGIS services. So Open Data has about 45,000 services that we support, and we suck out all of the data, translate it to GeoJSON, GeoHash, KML, CSV, and shapefile so that you can download it. So our stack today is we have kind of a Node.js app server, and we run a PostGIS cache to kind of hang on to all the data, although that's actually kind of gone away. We only use it for kind of a few kind of legacy features. Now we just use S3 as a big fat cache to store lots of big blobs of GeoJSON, and we have a distributed worker queue that we run with Redis. So all these things are kind of plugins to Koop, like the queue, exporters, things like that make up the Koop that we use for ArcGIS Open Data. So Koop's model is, as I said, it's very pluggable. And there's this concept of a provider, and that's the layer that talks to the remote API. So you can think of it as like a miniature Express app if you're familiar with Node. If you're not, Express is just a Node.js web server that helps you route things. If you come in on this route, do this function with this parameters. And you teach that provider how to talk to the remote API. So for Koop Egal, it knows how to talk to ArcGIS Online and figure out what kind of resource this is, and then how to import it into its cache. For Craigslist, it knows how to get that big blob. And some of these providers are just pass-throughs, for example, because an underlying API, like a Yelp, can support doing different kinds of queries, can support a spatial query, can support different kinds of filters. So Koop is really just passing it down to Yelp, translating that feature services query, and doing schema transformation, handing it back to the client. No cache at all. It's really, really simple, and something that can be created in the matter of an hour. I just made Craigslist this morning in like 30 minutes. So these things can be really simple when the underlying API is helpful. So it talks to the remote API, translates the response to GeoJSON, and then calls Koop's API, which may be like process feature server response, or export this file, or add a job onto a queue. These are all things that are kind of part of Koop that you get. And depending on the plugin, that cache may be something else, that file system may be something else. But there are lots of good examples out there. The most mature and the ugliest one is Koop Egal. It's really a full-featured application that does a lot of things. Koop Socrata is a really good one, too, for taking any Socrata data set and turning it into a feature service that you can bring into ArcGIS Online Web Map, or you can bring it into QGIS. CCAN and GitHub is a really good one. I think GitHub is a great catch-all, because as long as you can find a way with bash scripts and paperclips and glue to get GeoJSON onto GitHub, you can use that as a provider and run feature services off of that. So I think that's really cool. So then there is the cache. And the cache is totally optional. As I mentioned, you can write providers that are just straight pass-through, that are just doing that schema transformation. The reason that we use a cache is that it brings additional capabilities that aren't available with that remote API. So for Craigslist, for example, they don't actually have a GeoSearch. So if you want to do a GeoSearch, you need to do some post-processing. And there's a number of ways to do that. You can kind of pass the whole thing through a filter that you do on the fly. But that's not going to be as performant as stuffing it in like PostGIS and running your queries on it there. And then you can do other things in a performant way, like statistics. But it's kind of a choose your own adventure here. So there's the in-memory cache, which is the default for Koop, which is just a plain old JavaScript object. Just stuff it in there and pull it out with just big blobs of data. There's PostGIS, which is feature complete, and is, I'd say, the reference implementation for Koop's caches. Elasticsearch is experimental. We did it because we wanted to search across like 100 feature services and do interesting things. And it works just for doing spatial queries. I haven't tackled translating SQL into Elasticsearch JSON. I'm trying to find a way not to do that because it doesn't sound very fun. And then there's a Redis cache, which is totally hacked together, but it works. But the cool thing is the way that Koop's plugins work is that in your app server, you just register this cache, and then the provider can leverage it. It doesn't need to know whether it's a JavaScript object or it's PostGIS or whatever. It just calls Koop's API. And that's how kind of all the plugins work in general. They just follow a set API and implement these kind of abstract functions. And then we have kind of general plugins, because the goal for Koop is to keep the core as small as possible. And you'll see the work that I'm doing on our roadmap and our 3.0 branch is just pulling things that have been inside of Koop out into their own packages and making everything, don't make assumptions about what people are going to use. So today we're using Koop Queue, and that just offloads jobs onto a Redis queue, like exporting data. If you want to export like a feature service into shapefiles, KML, CSVs, etc. Koop Worker is set up to execute jobs on that queue. So it's really simple. It just listens to that Redis queue. The exporter is what we use for getting downloadable files from GeoJSON. And then the newest one, which is a new type of plugin, which is the file system plugin, is Koop S3FS, and that just totally transparently implements Node's file system API, everything except for the sync functions, if you're familiar with Node. So you just say Koop.register S3FS, and anytime you call Koop.fs within any of the providers or anywhere else, even internally within Koop, it's going to use S3 as its file system. It's pretty cool. It's just that's kind of the power of APIs. So we've got a couple other experimental providers that I want to call out. I think Koop Soda is cool because that was a community contribution from Tim Wisniewski, and it just shows feature servers aren't the only things that come out of Koop. And I'm working to make feature server right now is really the only first-class citizen for an interface where you can kind of what the client will consume, but I'm working to make that a plugin as well. So kind of anything will be able to access Koop the same way for any kind of format that you want to get out. If you have your own API that you want to run from ArcGIS feature services, Koop can do that translation as well. There's a Polygon geocoder which will find the name of an administrative area that best matches a bounding box. And there's the Koop tile plugin, which cooks vector and raster tiles based off of GeoJSON. It just wraps mapnik. And we'll be breaking out a lot more plugins before 3.0 final is released. So what does the roadmap look like? I think the message is that it's going to be much more modular. Koop has started out with this big catch-all lib folder, which had the S3 logic mixed in with the regular file system logic. It had the exporter, all this stuff mixed in. It had a query engine for GeoJSON, which is pretty awesome, but it was just hidden away in Koop without a clear API. So I've been kind of steadily breaking out these packages, and you can see them up in the Koop.js repo. GeoXform for translating arbitrarily sized GeoJSON streams into KML shapefile, CSV, et cetera. No matter how big it is, it'll pull that in and give you an output format. Winnow is for doing SQL on GeoJSON, so where clause and geometry queries against GeoJSON, and you can do this against streams as well, which is really nice if you're just passing data through. It's very performant. Feature parser just pulls individual features out of a feature collection, so you can work with really big GeoJSON blobs fast. All this logic was just inside of Koop that needed to be pulled out to kind of serve other uses, but they all now have better documented APIs as well. So really pushing on that documentation. But for Koop's API itself, I'm working to just simplify, pulling out the magic that it'll do, the things that weren't straightforward. It was kind of doing some magic. Fewer parameters, more simple calls. So it's easier to implement plugins. It's easier to write providers. An example of that is feature server. The implementation of feature server that we use on the 2x branch has 5 parameters that don't even necessarily make sense. I've gotten that down to 3, and I'm about to release that as its own package, so you can use that if you're working on the 2x branch, which is the stable branch of Koop. But yeah, I think the goal for me is PRs that are more red than green. Just pulling stuff out of the Koop core, keep it light so that if you're interested in contributing, the place to work is in the plugins, because that can do most of what you need it to. And so you can kind of watch that 3.0 branch. It's very much alpha, which means that I am breaking things. If you need stability, you can use the 2x branch. But the 3.0 branch is in production now for open data, because when I break something, I know and it breaks our integration tests, and I can get away with it. But still kind of dicey for using that. So I want to show you, all this stuff that I talked about. It actually does work. I can get this data from Craigslist into my house hunt map. So the story is, my wife and I recently got married, and we were looking for a house in DC. I built this Koop Zillow provider to help us kind of zero in, but we recently realized we won't be able to buy a house for like a decade, so enter Koop Craigslist, going to need to find an apartment. So this is actually nice. I actually did write this morning, and it works really well because Craigslist just gives you this nice JSON blob that has, location and a few attributes about the properties. So what this map is kind of my habitable zone. The dark blue areas, or sorry, the light blue areas are within like 10 minutes of a metro station on foot and 5 minutes in the grocery store. So really, great amenities there. But you can also see kind of the rail lines. It's kind of this frustration that Zillow and Craigslist don't have this contextual information that I need to make a good decision. I'm always going between the maps, and it's really frustrating. So what I did is I loaded a Koop container which had the Craigslist provider onto a little Kubernetes cluster, and there's information about that up on GitHub if you're interested in that, or you can talk to me about it later. I won't go too much into that. But what this looks like is it's just it's just a URL to a load balancer with kind of Craigslist is the provider, apartments, because there are other things that Craigslist does on a map, so kind of saving space in this routing so that we can do other things with this provider in the future. And DC is the market because that's kind of maps to Craigslist's API. So that's what this layer here is too. And you can see I now have all these apartment listings on the map, right? And dots on the map are useful, but once you get it into something like ArcGIS Online, we can start doing cartography and things like that. So let's make this into a little house. If I can find house. Right, so I can bring these in and check out some of the information. So broke the thumbnail, but you can see I can start to look at this information, and that's nice. But I can also do filters, even though Craigslist API doesn't support that. I can do filters on things like the ask, and I'll show you that. So let's do bedrooms. Oops, I messed that one up. And price is, let's say, if I do it too much lower than that, there won't be any apartments left in DC. So keep the price high. So you can see I'm able to do that filter, and that's really just kind of scratching the surface of things that you can do. And I won't do too much ArcGIS Online, but it's really nice. So I can look and see what's in my habitable zone and go from here to, so 2-bedroom place. I can look at the posting from there. So really, creating that link back to the original data is very helpful. And I also set up a couple other providers. So I set up Yelp, and let's pull off some of these other layers, make it easier to see. So the Yelp one is an example of pass-through, as I mentioned. So that's just going live to Yelp's API, making a bunch of requests at once, translating it into GeoJSON, and handing it over to Koop. So I can look at these, and I can do things like search on Yelp. Same thing with that filter API. Right, so I don't know if my search worked the way I wanted it to, but you can see I can bring in this information that is really useful for helping me decide kind of where to rent a house. But lots of business cases for this as well. So in the abstract for this talk, I mentioned that it's really implementing 2 functions, and I want to show you that it really is that easy, especially this Craigslist one. Let me make that bigger. Right, so I'm just going to walk you through what a provider looks like, starting from the routes, which I mentioned. So these routes just tell the model how to fetch data from the underlying API. So in this case, I've hard-coded apartments, but I can change that and parameterize it later if I want it to be like any kind of other like jobs, whatever, anything else that goes on a map. The city is parameterized as well, but it's hard-coded to DC. But this is going to just map things to the feature server. So all these different request types are just going to go through the feature server. So the gets and the posts. Then I have a drop because it's when you have a cache, you need a way to just clear things out of the cache. So the routes are pretty simple. And then here's the controller. So I don't really even need to do anything with this function. I can just use the boilerplate from the Koop sample app. But all it's doing is saying, when you get a feature server response, pass the parameters, which are like DC and apartments, and the query, which may be within this bounding box, are bedrooms greater than 2. Pass that into this Craigslist.get function, and it's going to return either an error or GeoJSON. I set a couple of parameters here just to optimize things, to tell Koop not to do post-processing on the GeoJSON, because that'll slow things down if it's paging or looping over every feature to see if it meets a filter. But then I just hand it off to Koop, and it does the rest. So you're looking at the 3.0 API, and the 2x is a little different, but I'll be releasing that feature server package so you can use it. So controller, really simple, and the model is pretty simple as well. So steps here are, first we check the cache to see if it's there. So request it from the cache, passing along, it's a type Craigslist, and the key is apartments in DC. That could also be programmatic. It's hard-coded for now because it's the only thing this thing is doing. But that could be jobs in Raleigh, for example. And it passes that query along because the cache, like Postgres cache, can do these different queries. Remember I mentioned early on that the reason that we have a cache is because underlying API doesn't support like spatial queries or filters like we want to do. So I pass that down to the cache, and it responds with GeoJSON feature collection if it has that. And then I just call back and hand it over. If it's not in the cache, I fetch the data. And once I have it, I just send it back to Koop. And in the background, I insert it into the cache. So that's what I'm doing here. So just returning that, so the response goes right away. And inserting it into the cache. So that really isn't even something that you need to implement on your own. It's really total boilerplate. Here's kind of the specific stuff to Craigslist in this, the functions that you would implement. So this one called fetch is given the resource, which in this case it's hard-coded to apartments in DC. Given that resource, how do I get the data from the underlying API? So that's one of the key functions. You could think of it in the abstract as given the set of options, what is a URL? But you can also kind of push down predicates if that's available. So I get the JSON, and I hand that off to this function called translate, which is the other one that you'd have to implement. Every provider will have to implement its own translate function unless it's already handing back GeoJSON. So here is where I just kind of filter out. So like Craigslist's API is a little bit weird. They mix their clusters with the actual listings. I don't know why they do that, but they do. So I just filter out the ones that aren't actual listings. So that first step is filtering out ones that don't have asking price, which is just a heuristic for whether or not it's a listing. And then I just format it. And that's, again, not very complicated. I'm just taking things that are in that Craigslist JSON, like the posting title, the asking price, the number of bedrooms. And the reason I couldn't filter on that the way I wanted to is because I need to parse the float. So munging the data a little bit, right? So we have what we want. Maybe there's fields that we want to rename, and I did, like the price is called ask. I wanted to change that. That's why I do that all here. And add things like the thumbnail, which I need to add a protocol onto this. That's why it didn't work. But that's it for the format and the translate function, right? So Koop Yelp is really not more complicated if you look at that one. And I want to show you that one because it's just a nice example of a pass-through provider. It'll load. And actually, one thing I want to show you in the controller is that the extra step here is that we need to trick the ArcGIS.js API when you have a pass-through, so it'll make tiled queries. So you just return the count as greater than 1001. If you're trying to do a pass-through, just kind of file that one away so that you know why it's requesting data in a way that you don't want it to. So again, this looks pretty much the same. I called it search instead of get because that's just fits with Yelp's API. But here as well, I've implemented search, and I made this a little more complicated because I wanted to do 8 searches at once because they only give you 20 data points, but you can page once and you can split the bounding boxes and do all kinds of things, or async and node. But the thing I wanted to show you was just this format feature, right? So just taking a JSON schema and translating it into something else. That's really like the meat of Koop. And it doesn't have to be complicated. Just putting the location where it needs to be. Everyone with their own API specifies location differently. So I had to translate the coordinates in this case. But that's all it's really doing. So it's not that complicated with a lot of these JSON APIs. So with that, I just wanted to mention some resources, and I'll upload these slides and I'll tweet them out. You can find me at @dmfenton. But the best resources to look at if you're interested in Koop are koopjs.github.io. That's our main docs page. That'll give you some information about it in general and point you to the officially supported providers. Koop is the main repo, that kind of core where all the plugins happen. It's got the roadmap. It's a good place to put issues on GitHub. There's a sample provider, which is that layer that talks to the API that shows you how you might want to implement it. There's a sample app. So to run Koop, you need to have an app which uses Koop, which is Express middleware. So it's just kind of a plug-in to Express. Koop Docker in my repo is an example of running Koop in Docker on Kubernetes with lots of instructions there about how to get it running, just something that I've been experimenting with. Instead of one big Koop, I'm running little micro Koops that have one provider and don't kind of step on each other and crash. And I think this video is good. That's Chris Helm's talk from Esri Development Summit a couple years ago. So Chris is the original developer on Koop. Many of you know him. And he's got some great ideas for how to use the thing and a great perspective on it. So with that, I'll ask are there any questions?
I have a question. What does it make this specific to GeoJSON? Why couldn't you retarget a different target form? For example, if I wanted to collect data from sensors, and they all do it a different way, and I wanted to target a sensor standard.
Sure.
Not GeoJSON, something else.
Sure.
What would it take to
GeoJSON is just the intermediary format. So it's for the example of feature servers, it's not the final output. It's just a nice format that like the cache has been written to work with GeoJSON. The exporter has been written to work with GeoJSON, but you would write a plugin like the feature server plugin that would take GeoJSON and then translate it into your other format. You could do straight pass-through within your own provider and just translate it once, but you would lose the advantage of being able to use Koop's cache. So as I mentioned, it's kind of the lingua franca inside Koop, not necessarily for the outputs. So you could absolutely use a sensor format or something like that.
what makes it, why do you require GeoJSON for the caching, for example? What are you taking from the
Sure.
GeoJSON that makes it special for that?
Sure. specifically with like PostGIS cache and Elasticsearch, for like things that don't have a schema, PostGIS works really well with JSON. You can do kind of JSON selectors on arbitrary things. If I had a very specific schema, I would have to know the schema of every feature beforehand, which it might be different because Koop does this. It selects the type at runtime. And so there's just a lot of logic for how to do like spatial queries on GeoJSON and things like that, which I can't write that to do it against every way. Same goes for Elasticsearch. It works on JSON documents. I can't write it to do things every different way, and I can't write all the default plugins to work with all these different formats. So you don't have to use it, but it makes your life easier.
Could you write something that says, here's a schema, here's XML, schema in plus XML in Koop/GeoJSON?
Conceptually, absolutely, and that kind of schema translation is something we're really interested in as an R&D project and bringing into ArcGIS Open Data, for example, an XML or a JSON document that says this field maps to this field. And I think you'll see work with Koop plugins doing that this year. So absolutely, we want to do that. It's really cool. And there was another question.
How much of the feature service API is supported, especially for the JSON?
I'm sorry, and I've been forgetting to repeat the questions, but the question was how much of the feature service API is implemented? Yeah, really the basics. So the query API is implemented so that you can do, I'm sorry.
Query API is very big.
So yes, you can do kind of where clauses with the query API. So where bedrooms greater than 2, price less than 3,000. You can do geometry queries. So within, contains, intersects. You can do out statistics. So depending on which cache you're running, but I'm working to have that within the feature service implementation itself. So if your cache doesn't support that, we can still do statistics and things like that. But basically, the bedrock of the query API and also like info. If you want to get feature server info, so that you can plug it into ArcGIS Online and do basic styling or heat maps or things like that. I actually mean the question was what is the spec for the feature service? In this case, it is the feature server spec. Sorry, not feature server, but the GeoServices spec, which is Esri spec that we've donated. You cannot do it out of the box. There's an issue, an enhancement request to do a WFS plugin. And the work that I'm doing right now is to make these kind of interfaces work as plugins. So if you had a use case and you wanted to write a WFS plugin, you could do that. Just like there was a SODA plugin that was written for that specification. So it doesn't exist today, but it's absolutely possible within the architecture of Koop, and it's welcomed. Sure. The question was, how am I handling stylistic information? And the answer is that I'm not. Just the raw features and let the client, the styling happen client side. That's what I was doing with the ArcGIS Online map viewer, just using it to style things. I think we may add a few different aggregation renderers and things like that. Yeah, it's just the raw features that we're working with. Yeah.
Are you aware of any comparable tools? Like, is there anything else? Like, what exactly is the category of things that Koop is in? Is there anything else like that?
I think safe software is comparable, but that's more of like batch processes versus like Koop is meant to work as a web server and do things on the fly. If data's not there, it'll go get it. If data's expired, it'll go get it and kind of keep things up to date. But that's one good example. Yeah. All right. Thank you very much for coming.